Mr. Minnick here, help with collision detection worksheet number 1. In this situation here, we have some code that's not shown. It doesn't affect answers further down the worksheet, so you can just ignore that. We have a function draw maze. I didn't use blank lines. It still works. You should be able to trace it. So grab a piece of graph paper or carefully sketch a little sample grid on your margin and send your cursor, your turtle rather, to -200, -200. Put the pen down, pretend that the pen's down, go to 200, -200, which would be the point over here. That draws the lower boundary. 200, 200 would be that point. And then this point would be here, and this point would be here. So we have just drawn the border of a maze like the one that we spent the last week programming and coding in class. Okay, where is horizontal line H1? By identifying these two endpoints and drawing the line that connects the dots, you have a point that's roughly, say, from here to here. That would be H1. The important thing is that you know that the x-coordinate of this point would be 40 on the x-axis, and the x-coordinate of the other endpoint is the point -120 on the x-axis, and the y-coordinates for both points would be 120 on this y-axis that goes vertical. You should understand how to draw a line represented by two goto function statements. Okay, the same way, H2 is a horizontal line that goes from, say, -40 to 40. The pen would go to -40 and be probably about right here. And it would go to 40, 40, which would be the point roughly here. That would represent H2. This point on the y-axis would be 40 if you extended that line right there. And these 2 points, -40 and +40, would be represented up here as the x-axis coordinates of these two endpoints here. And lastly, let's quickly sketch out vertical line B1 from -120, +120. So that would be a line that starts here, and it would connect with -120, 40, which would be about right here, I believe. What a coincidence. That's at the same horizontal placement as both of these points, and they're lined up vertically. And that's V1. Now let's answer some of the questions that are found on this worksheet. You're supposed to just, again, assume that these functions work like they did in previous demo programs and the assignment that you probably spent the last week coding. We now have to fill in these blanks. I'm giving you enough surrounding code for you to analyze and fill in the blanks without feeling that you have to memorize things. First, let's deal with this right boundary. What would go in here? Well, it's got to be a less than or a greater than sign, and it's going to be a number. Well, the right boundary is over here, and because of what we learned with collision detection, when the mouse or the cursor, the player, is moving right and hits this line at the moment of impact, or probably when the center of the turtle hits this line, the point on the x-axis is -200. So detecting a collision with the right boundary is a matter of checking to see if the x coordinate, the center of the player, is greater than or equal to 200. The left boundary, there's nothing to do there, negative 200, that just works. That code, of course, detects the player hitting the left boundary, that would be over here, where negative 200 is on the x-axis over here at this left edge. Okay, our next problem to answer on the worksheet is to fill in the blank here for this else if. Okay, let's pretend that we don't know which boundary this is. It's either the top or the bottom. The right and the left are taken care of. Top or bottom. Well, what if the player is greater than 200 on the y-axis? We have to now consider the y-axis. Being greater than 200 on the y-axis means that the player is up here somewhere, greater than this point 200 on the y-axis. The point down here at the end of the y-axis would be negative 200. So if the player reaches a spot where the player is, the y coordinate of the player is greater than 200, that means you hit the top boundary. So let's fill in the code that we need to. If the player's y, represented in code here as player dot y coordinate, you need the empty parentheses here, and it's just COR, as you see everywhere else, and that's the top boundary. This missing fill in the blank, by deductive logic, it must be the bottom boundary, in which case the y coordinate is getting lower than the bottom edge of the screen, less than negative 200. Represented by if the player hits this line in the center of the player, hits this point where y is negative 200, you know you've collided with the bottom boundary. So there you have it. Fill in the blanks for the check collision function. And now we have to consider these inner walls. H1, H2, and V1. Let's look at H1 first. For H1, we're concerned whether either the y coordinate or the x coordinate is greater than or less than something. Again, we're talking about H1. So let's look at our little diagram. If the player hits H1, that means that the center of it, vertically speaking, its y coordinate is equal to 120, positive 120. And we have to use the double equal symbol to represent touching a line. Double equals 120. I wish we could just write the letter y here, but we can't. We have to refer to it as player dot y coordinate, empty parentheses. For line H2, some of the code was already given to you. Y coordinate equals 40. Does that make sense? Sure, because for H2, right here is where the y coordinate would be at this point 40 because of where we drew this horizontal line number 2, H2. So far so good in our answer here for line H2, but we need to fill in all this. Well, let's just copy this and tweak the numbers if we have to. Sorry about that. Player dot x coordinate greater than or equal to something, and player x coordinate. I'm just going to write P because I don't have room to write player. Dot x coord less than or equal to something. What are these two somethings? What numbers are such that, I know this is sloppy, what are the numbers such that x coordinate is greater than or equal to some number, and at the same time less than or equal to some number right here. Okay, well, let's look at line H2 to decide if the circle collides with H2, from the sides of H2, if it's coming here from this side and it collides, it ends up becoming greater than -40. Greater than or equal to -40. Greater than or equal to -40. And from the other direction, and player.x coordinate, empty parentheses, greater than or equal to. From the other end, it's represented by the player hitting in this direction to the point where it becomes less than 40. Less than or equal to 40. Less than or equal to positive 40. So we have a greater than or equal to -40 and player.x coordinate less than or equal to 40. Sorry for the sloppiness, but you could always replay the video and listen to me speaking. Okay, our last set of answers for vertical line B1. In this case, it's the opposite. Instead of y coordinates for horizontal lines, you care about the x coordinate first, being equal to something, and I gave it that to you. The x would be equal to -120. This -120 here is what tells you whether the player has touched that line. But what if the player hits the end of this short vertical line 1, or comes from the top and hits the top end? Well, if it comes from the top and hits the top end, at some moment, its y coordinate becomes less than 120. Y coordinate less than 120. Y coordinate less than 120. And really, this is, we don't even have to think about the number involved here. This is also y coordinate less than or greater than or equal to 40. Good luck, and talk to you the next time.